Hello, everyone. Welcome back to Paris Air Mobility. As Juliette said, I am Sean Broderick, Aviation Week's Air Safety Editor, and I'm about to learn a whole lot the next 40 minutes because I don't know much about this industry. So I'm excited to have a very experienced and diverse panel in terms of representation up here with me. Again, the discussion is going to be creating the airspace of tomorrow. I have a whole bunch of questions, and I can ask questions all day. That's my job. But we are here to serve you. So I believe we have a Slido function going where questions can be input via the inner tubes, and they magically get up here into this iPad, and I can mix them in once we start rolling. So without further ado, what I'm going to have each panelist do, introduce themselves, name, title, and a little bit about their role or their organization's role in the industry. So we're going to start to my left with Dan. We're going to go on down. Then when we're done, we're going to get into some question and answer. So kick us off.
Wonderful. Okay, good. You can hear me. My name is Dan Dalton. I'm the Vice President of Global Partnerships at Wisk Aero. And at Wisk, we're looking to certify the first autonomous AAM vehicle, or eVTOL aircraft. So we actually have it here on the screen. This is our 6th generation aircraft. The previous 5 have been built over the last 13 or so years. And so what we believe is that the way to truly unlock the abilities of AAM is through autonomy. So this aircraft has 4 passengers, and it has a traditional sort of back end to it, but then you'll see on the front it has also the tilting rotors to provide that lift and then that transition to the horizontal flight. Again, there is no pilot on board the aircraft. We are going straight to autonomy, and we do believe that autonomy is actually now, because we're linking together so many parts of an existing chain of automation that exists in the NAS today, and so now we believe that that opportunity exists for all of us to be able to enjoy autonomy as it relates to air mobility. So that's kind of where we are. So,
Good.
Thank you. I'm Marc Devaldestin, head of the strategy for the flight avionics business in Thales, and former head of engineering in this business too. My role in that is just to make the avionics pivoting in several directions. Of course, we have to go to these marvelous full electric devices where we have to be really much more compact we were before. But we also have to pivot in other directions. We have to connect the avionics to the connected world. We have to make cyber. And we have also to propose the way to have AI-powered concepts. So that's, and still being safe. Safety is our main job. So that's my role, not always obvious, even when we have potential partners who are very expecting from us a lot of things. But it's a fantastic job.
Valerie.
Yeah, hi, so my name is Valerie Manning. I'm the Chief Commercial Officer of Overair, which means everything to do with going to market, including the operations. So Overair, we have what you see here, which is our butterfly aircraft, which is an all tilt rotor, all electric, all fly-by-wire vehicle that we plan to fly in most weather conditions, in very many use cases, passenger, cargo, medevac, because we have the size to be able to do that. And so, yes, we're in the process right now of building our first full-scale prototype. We've already proven out this propulsion system full-scale last year on a truck test bed, proving out our optimum speed tilt rotor and our individual blade control. There's a lot of technology behind what enables us to be what we believe is the quietest. We have extremely large propellers, twice as big as the next eVTOL, that are turning very slowly. And we really think that noise is the key, lack of noise is the key to really unlocking both in urban and rural areas, urban air mobility and eVTOL. So happy to talk about this a little more.
We will.
Well, hello. My name is Antoine Martin. I work for the French Civil Aviation Authority, for the Safety Directorate. And my role, so I'm not from the industry, I'm from the regulator part. Despite, of course, I also support the industry, and especially on the matter of advanced air traffic management. And to put it simply, I'm the focal point for UAS traffic management, and we call it Airspace in Europe, as you may know. Thank you.
Hello, everyone. Good afternoon. Good morning. My name is David Rothblatt, and I'm the Vice President of Sales, Marketing, and Government Affairs at Eve Air Mobility. For those that aren't familiar with Eve, we're an organization that spun out of Embraer X, the incubator of Embraer, in 2020, and we went public on the New York Stock Exchange in May of last year. We're a very unique urban air mobility company in that we make much more than just the eVTOL. We're also focused on a services and support product line, as well as an agnostic air traffic management software that is a product of the great work that Embraer has been building and executing for many decades. Eve has been very, very focused on community engagement, one of the significant resources that exists in order to create a path forward to enable the safe scalability of urban air mobility. And to that end, we recently shared some exciting news where we're starting to engage our operators in the launch markets that they intend on flying in, specifically and most recently San Francisco with United Airlines. And this is an example of what we're doing to prepare not only our operators in the launch cities for how urban air mobility can get ready for day one operations, but also to start understanding the airspace as a resource, current barriers to scalability, and how it can create safe software and safe procedures to allow this industry to grow, of course, with you, the passenger, in mind. Thank you for being here today.
All right. Full service OEMs, tier one supplier, and a regulator. This is going to be a fun 39 minutes coming up. All right, so Dan, I'm going to start with you. Straight to autonomy, all right? The question, and each of you are going to get to answer the same one, how will the AAM launch look in your mind for both passengers and cargo, accommodated into what we know today, existing infrastructure and airspace? You can go macro or you can go micro. You can go right into your launch cities, or you can talk big picture. Yeah. Have at.
Excellent. Well, I think this industry in particular has realized that in the past we maybe had a lot of CGI and a lot of graphics that showed that there was going to be so many aircraft that it was going to darken the skies. I think now you're getting to a place where the designs of the aircraft, the understanding of the airspace itself, are all kind of bringing forward this idea that we will have modest entry into service, all of us will, that it's actually going to be a bit of a migration or an integration of aircraft into the airspace versus a sudden explosion of aircraft all over the place. And so with that reality and that understanding, you're also seeing a lot more people who are coming from legacy aviation into each of our organizations and who understand that this is not just about quick flash in the pan, but an actual opportunity to provide services for many years to come. And so if we do that methodically and safely especially, that is the best way for this industry to grow. And so for that reason, we all work very closely with regulators to make sure that there is airspace that we are sharing, because we believe, at least at WISC, we believe that the airspace will be shared between piloted aircraft and uncrewed aircraft for a long time. And so how do we safely integrate into that airspace, whether it's through passenger operations like we're doing or others are doing with cargo? How do we safely bring this about to ensure that we are making the right steps forward to safely bringing this about? So, yeah.
Mark?
I think we are 100% aligned on that. Certification is not the key. It's mandatory, but behind certification, we are speaking of safety. Without safety, no sustainable development. That's so obvious. So for us, we have some type of contradictory expectations in front of us when we are tier one. You have to come with a very sure and mature concepts when you push some solutions and equipments to the players. But you have to make it quite different from what you haven't ever made before. And as I said already, very compact, connected but safe, adapted to these fantastic machines which have architecture we've never seen before. So that's really, for me, it's a driver for transforming our industry. And at the same time, we want to transform the way we are going to see the aeronautics. So there is this discussion about full autonomy, partial autonomy. In fact, at the end of the game, we'll need to have very powerful technology to connect and to give some intelligence to the system. And at the same time, we have to be very basic on the safety nets that we are going to push. That's our challenge, and I hope we will be able to satisfy you.
So we need to be able to deploy the aircraft for both commercial and operational success. So at Overair, we will initially operate in a couple of locations in the US on our own, mostly because there are no operators today. And as some others, we are thinking not only about the aircraft. The aircraft is the first step, but we need efficient aircraft, we need efficient operations, we need to be able to ensure that the aircraft is available, that we understand the charging, we understand the issues, because if the aircraft cannot operate consistently, if the operator cannot depend upon the solution, then we will not be able to scale and then be able to sell those aircraft more in the future. So for passenger, we're going to be looking at specific operational areas, starting more with some specific and planned routes that then we scale from. We believe strongly in this, and then with the network comes the scaling and then increasing the challenge of operational efficiency. On the cargo side, that's where, there are the companies who know what they're looking for. They define efficiency in cargo. In this way, we'll be doing more of a third-party deployment, support and services to enable the sort of middle-mile cargo opportunities that they're looking for. So really, it's not just the aircraft, it's about everything around the aircraft that we think is the key to starting the operation.
Makes sense.
Well, I pretty believe that in the long term, crewed and uncrewed aircraft will fly all together in an integrated airspace. However, it's not feasible right now. I do agree. It's a target. And how can we achieve that? In Europe and in France, we have a very pragmatic approach, as in the US. We do it step by step in an iterative way. And we start with low-risk operation. And we have a roadmap, for instance, for AIM, Innovative Air Mobility. You know the European term for AIM. We have three types of operations. And so we start, for instance, we will start in Paris with type 3 operations. It will be conventional air traffic management, controlled aircraft with a piloted aircraft. It will be AAM, but it will be in pure ATM, so that's type 3 operations. Then we will target type 2 operations in urban areas with URS traffic management and also eVTOLs with passengers, but that's another step. Once we are confident enough that the eVTOL aircraft can be safely managed. And at the same time, we are implementing Airspace for traffic management of UAS without passengers on board. And once we'll be confident enough that the infrastructure and the system, the procedures and the providers are safe enough, then we will be able to move to a further step.
Thanks, Antoine. So Yves has taken the very unique approach of focusing on that community engagement piece that I mentioned earlier. And in doing so, we've co-authored over 8 different concepts of operation with organizations like the Japanese Civil Aviation Bureau, Air Services Australia, the UK Research Institute, the RKRI, where we partnered with London City Airport, London Heathrow Airport, NATS, and 5 other organizations to co-author a ConOp there. We've also done simulations in both Chicago and Rio, as well as in Bangalore, India. And so in many of these places, we're learning firsthand what is required of the local operating environment, what does the local regulator have to say, and what do the communities have to say. In each of these cases, we've learned how much variation exists city to city, and because advanced air mobility or urban air mobility is at times very city-specific, it's important to understand what currently exists and what needs to be added in order for us to get ready for day one operations. And so that's a lot of what we're focused on at Yves. We've learned a tremendous amount about those concepts of operation, and I think one of the things that is really important for us to consider for the safety case and getting ready for day one is understanding the needs of cooperative surveillance, both for crewed and uncrewed aircraft. I think that we've seen that the technology exists for how crewed and uncrewed aircraft can operate in the same type of airspace. We see both civil and defense organizations doing that every day. And the technology has been proven. Now it's just a matter of how do we do that at scale and at a commercial level. And so as we solve the different types of opportunities that exist for things like cooperative surveillance so that we can have visibility with each other and understand how we can deconflict from each other, especially in uncontrolled airspace, I think this is one of the great opportunities for urban air mobility and advanced air mobility for operators and manufacturers to tackle alike, so we know how we can make sure that we're properly equipped to see and avoid, again, for both crewed and uncrewed aircraft.
All right. Okay, so we're past day one. We have vehicles flying reliably. The system as you envisioned it is working with the tools that we understand now. Let's talk about step two from an ATM perspective. How do air traffic management systems and technologies evolve to help scale this? So I'm going to start down that. I'm going to start with Antoine, the ATM guy.
Okay. Thank you, Sean, or not, because this is a tricky question. Again, we all have scalable approaches for integration of AAM into the airspace. I think that the key is learning by doing, again, to keep the risk sufficiently low. However, we know that it will be difficult at some point, for instance, to implement interfaces between conventional ATM and autonomous aircraft or autonomous air traffic. And this is something quite tricky that has still to be that still need research and development, in my opinion, and that's why it's in the European strategy, drone strategy 2.0, and at some point we are also convinced that air traffic management actually will be an enabler for advanced autonomous operations, because whenever for instance, Uspace or UTM is not able to provide this sufficient level of safety, ATM will be able to do so. But at the same time, the interface between ATM and the autonomous air traffic is still unknown, and this has to be worked on.
Stay down there. David, tap some of those papers you talked about.
Sure.
And pull out those sections and highlight them for us.
Sure. So I think one thing that's interesting to note is that while many people might think that the urban air mobility industry is something new, it depends on where you are and what context you're thinking about. In countries like Brazil and cities like Sao Paulo, for example, the air taxi industry has been vibrant, alive and well, and growing. There's as many as 1,300 air taxi flights every day in Sao Paulo. And so we partner with organizations, for example, like Helisul, that have decades of experience operating throughout Brazil to help learn with a trusted operator like Helisul and other operators that we have in Brazil, including Flybeast, Voar, and others. What is their experience working within those conventional procedures that we've co-created with the local air navigation service provider, which is DSEA in Brazil, together with the air traffic control software that the Embraer Group produces today. And so we've learned what are the opportunities to improve not only the procedures that we've co-created, but also how to make better use of airspace procedures that we have today, so that we can somehow identify the opportunities for improvement, number one, understand how we take advantage of the existing procedures and things like we have in the United States, for example, whether they're transition routes, VFR corridors, existing helicopter routes, but prepare them for eVTOL-specific operations. And so one of the things that I think all of the manufacturers care about is how to get from point A to point B as efficiently as possible. We're all using some form of energy other than fuel to get there. And for Eve, for example, we're 100% battery powered. And so the ability to fly as direct as possible is a new type of procedure that we're going to need to co-create with the local ANSP, the ATO office, for example, in the United States, to build procedures that are ideally, at least for eVTOLs, if not for others as well, so that we can go places that conventional helicopters couldn't go before. And so the ability to identify what types of existing procedures we can start with is important. I think the initial volume of eVTOL aircraft that will be introduced into the airspace in every country around the world won't necessarily threaten the current paradigm of air traffic management. It's really when we start to scale that those existing procedures are going to need to be modified in order to allow for the safe scalability of the industry. And so what we're doing is identifying what those procedures are, working with our trusted partners in places that are already very mature in their operations to learn from them, and to help inform some of the software that we're building in Eve that is designed to interact with conventional air traffic management software through APIs that will allow other third-party service providers to tap into the software that we're building, as well as vertiport companies, other operators and manufacturers, so that we can all see each other and share information. And I think that's the key, is sharing information, not only about where you're going and where you're coming from, but your intentions. And I think that's going to be one of the biggest pieces of information, the data, that we can be sharing with each other.
Sure. We're going to talk more about software. We're going to come back to that subject, but working our way back up here, Valerie, how does ATM advance to help Overair get to where you guys are going?
You know, it's funny. Just last week, I was back in Toulouse, where I've spent 13 years of my life, and I was flying, and I was doing an approach, a short IFR flight, an approach into Toulouse-Blagnac, and on autopilot, I'm just sitting there and waiting, and then I get India Alpha, my aircraft, can you do a 360-degree hold to the right? And I'm like, okay, heading. Then, can you do another one? Okay. Then at about 340 degrees, okay, stop, take this heading, okay. 2 seconds later, okay, descend, change your transponder, okay. Okay, another heading, call back when you've intercepted and you're on the ground, right? So, and it's fine, and it was fun for me, by the way, but then, you know, just before I came here, I fly often in Northern and Southern California. From on the ground in Oakland, California, to on the ground in San Jose, two relatively small airports, 21 minutes in my aircraft, ground to ground. I have 7 frequency changes, and I talk to 3 different people. So, and it works very, very well. So existing air traffic, yes, it needs to evolve, but first we need to evolve. We want to work there. We don't want to wait. We are going to work within the existing systems, and then, yes, be able to work on how can we communicate without always having to talk, what's the next level of text, et cetera. But we operators, you know, we need to guide. So things never go as planned in aviation. So yes, we look for the evolution. We can guide, we can give, you know, we don't really want to be segregated. We have to show that we can adapt and to, you know, work together on how we're going to help evolve. But, you know, I just want to make sure that the evolution will come with time, but we don't want to wait for that.
Well, it's a great point. AAM, in a way, maybe dragging global ATM where it needs to be going, regardless of what's coming vehicle-wise. Antoine, what do you have to add?
Okay. First of all, I think for this ATM to evolve, it needs also some technology enabler. I feel 3 of them. The first one is really high-density connectivity, because for this cooperation you are asking for, we need really board and ground cooperation, that's obvious. The second one maybe is sensors cooperation for everything, for traffic avoidance, but also for guidance and so on. And the third one, and last but not least, is a tremendous gap and step to be done in positioning and guidance technologies. 3 ones. So you will be sure that the ATM, the UTM, will know exactly what the aircraft is going to do and on an optimized operation.
Excellent. So they said all the smart things, which is great. So the reality for us at Wisk is that we've actually issued a ConOps on what we believe the future of ATM will look like in partnership with Boeing. So Wisk is also a wholly owned subsidiary of Boeing, as just a few weeks ago. And so with that concept of operations and the FAA's recent concept of operations, which they just issued as well, which kind of points to this idea of digital flight rules and digital corridors. So we fully appreciate and actually really like the idea of having these tubes in the sky, but how we get there today is going to take an evolution. It's going to take a lot of research and honestly a lot of demonstration from our side. In fact, David and I were just talking about it before we came up. How do we collaborate to help build out those standards that we as an industry want to use to really drive the ANSPs? So for us, at Wisk, we're starting with IFR. So IFR is a very well understood architecture, and one of the best things about it, to Mark's point, is that it describes intent, pilot intent. And so when you go into a structured system where everyone understands what your intentions are, the first part of it, that's the easy part. Now you start dealing with contingencies. What happens if you no longer know the intentions of that aircraft? What are the backup plans for the rest of the system to understand, well, we all know that, for example, there's no communication with that aircraft. What is that aircraft's intention, even if it doesn't have the ability to communicate? We've built that all out in the existing infrastructure. Now, how do we translate that to digital and then show that it actually is safe? And at times, it could even be more safe, because if you're sitting there spinning a dial, so we're all pilots, so if you're sitting there spinning a dial, I guarantee it's happened one time, maybe just one time, where you spun the dial, flipped the frequency, and no one was there. Because maybe you missed it by just one digit, but maybe even a tenth of a digit. And you go back to the other person, you say, I think I missed that last digit. They say you did, you go back again. All of this does not have to happen if we have digital communications, where the aircraft, so an example of that would be a data link between the aircraft and the air traffic controller, where the whole message is digitally sent to the aircraft, and then the aircraft confirms it receives it, and then the aircraft is allowed to depart. We have that technology today. In fact, we use that at many airports around the world today. Now it's just a matter of how do we show that we can do that with an autonomous aircraft. And for us, that's not just when we say autonomy at Wisk, which is also an important definitional point, when we say autonomy, we're talking about no pilot on board the aircraft, but we actually have human supervisors who are watching over the aircraft. Every single flight is monitored by a human to make sure that should any of those anomalies occur, we have backup and backup and backup, especially with a human. So I think it's a matter of how do we take those existing architectures today. Many ANSPs have a vision and they have articulated their vision, but we have to, as industry, drive that forward and pull together that data to show that this is safe.
All right, 19 minutes to go. We're not ignoring you over here. It's the setup of this stage. I feel like everybody over here is sort of getting ignored. We know you're there. We sound good. All right. Okay, software. We mentioned software a few times on the last go-around. So what is software's role in making what we've been talking about for the last 20 minutes work? How does it help AAM's evolution? I'm going to, David, you mentioned it, so I'm going to go down to you. Software.
Software. So I'd like to quickly just answer that question by going back to what Dan was just talking about. As at least several pilots on this panel, and I'm sure many in the audience and those listening, when you're in controlled airspace, and even when you're not, sometimes there is just an almost comical inability to find an open spot to communicate your position and get your instructions, especially when you're coming into controlled airspace, in particular in Charlie and Bravo airspace, at least in the United States. And when we think about that, that's today's current volume of aircraft, both commercial and general aviation aircraft. And then when we imagine a future of that many more piloted aircraft, eVTOLs entering the airspace and also fighting for attention from controllers that are only allowed to talk to so many people at one time before they need to turn people away, it's just physically not possible to manage so much more volume than what the controllers are already doing. If you'd like to, I think it would be interesting, whenever you'd like, to go to a website called liveatc.net and type in a 3-letter identifier, whether it's MIA, JFK, LAX, and you can choose tower, ground approach. You can just listen to the controllers. They never stop talking. And so the software that we're developing in EVE is designed to evolve from voice-based communication to more autonomous forms of data exchange in order to allow for at least a way for the volume of aircraft that we all collectively aspire to introduce into the airspace to continue to grow without having physical voice-to-voice communication being a barrier to the industry's ability to grow. And so, as Dan was saying, there's so much digitization of information, like CPDLC, for example, that's used today, and we're creating more options and more ways of sharing information that can be beyond voice-to-voice communication. Earlier, I mentioned cooperative surveillance, and I think that there's great software out there today where if you have an ADS-B in receiver and you're automatically ADS-B out, because at least that's required in the United States, you're allowed to see and have so much more information at your disposal. And so what we're doing at EVE is partnering with not only Embraer, which has an existing full stack of air traffic control software that's used today, but also working with our third-party partners to develop the right type of software that will allow for this evolution. The other thing that I think is interesting to discuss, we might not have time for it today, but is the minimum equipment list for the aircraft. So what type of hardware and software does the aircraft need in order for it to be relevant and for it to cooperate in that type of cooperative surveillance environment, so that that type of information is provided to either the pilot on board the aircraft or remotely piloted aircraft, or to the software that's negotiating that rapid exchange of information. And so I think that whether it's ADS-B on the current frequency that we have in the United States, or perhaps opening up a second one because that frequency is unfortunately already so saturated, there's a lot of opportunities at our disposal. I think what it's good for you to know is that organizations like OverAir, WISC, and many others are partnering in trade associations, of which there are many, to help define collectively what those standards should be so that we can recommend them to US regulators, to regulators all around the world that we plan on selling our aircraft into, so we can standardize what that vision should be and then we know what we can work towards.
All right. I'm not going to make each of you answer this question, but anyone else wants to talk software? Valerie, you look like you want to talk software.
Yeah, I'd love to. I mean, look, I'm sitting up here, but I represent just a fantastic, phenomenal team at OverAir in California and other places. And there's, it's really software based. We're sitting here talking about aircraft, but there's a lot more to successful mobility than aircraft. There's intermodal. You got to get to the aircraft. The aircraft is producing data, and we are developing a software suite where it's basically the hub, both from an operator point of view and an OEM point of view, where, yes, we're going to tap into things that exist, existing EFB, existing MIS, but there's a lot that we need to do to make sure that, again, we can operate efficiently. The aircraft will be producing a lot of data. That's one advantage we have. And we're going to, we have to take that data so that we can get to, which traditionally aviation is using as well, these predictive ideas, the aircraft telling you, I don't feel so well, so that you can swap earlier, right? The passengers as well, right? The passengers need to be able to tie in to this ecosystem, and we need to be able to tie the passengers into the ecosystem. So the software has to be able to anticipate, especially if we're going to scale with commuting, to say, okay, this passenger wants to go from here to there. The passenger is not going to say, I want to go to that vertiport. They're just going to say, I want to go from here to there. The software is going to be able to tie in. We have to share this aircraft. And so probably it's better to go to that vertiport than that vertiport, because that aircraft still has 2 seats left in it. So really there's a fantastic team that's developing this ecosystem and using existing software where it exists. But in some cases it doesn't. So basically, the health of the aircraft, the mobility of the passenger, and then the ability of the OEM and the operator to manage this ecosystem. So yes, it's extremely important to, again, have operational and commercial success.
Software. Anyone?
Software, yes. In fact, UTM is a software-based system. But it's not exactly the classical software-based system that we have today for the ATC systems. It has to go to the digital large data platforms. The exciting thing is that we are going to need different type of software technologies. Of course, we still need to have the mandatory classical certified software. We need it, but it's not enough. And we need to have it exported in other places, in other spaces. For instance, today we export our FMS core out of the aircraft because we need to have the model of the behavior, the model of the intent, that you say, done outside. And last but not least, today, what we are developing now is being able to have also AI co-working with the classical deterministic software. And that's not only software now, it's a concept. How do you mix a safety net, you know exactly how it will go, with a powerful software which is able to do fantastic things, but sometimes not predictable? That's the key point, and that's where we are focusing our efforts today.
And for WISC, I'll go with the deterministic point. For us, we appreciate that there is so much automation that exists. I'm going to look over here too, just so you know. I'm not looking over your shoulder. I'm just looking at these folks here. Yeah. There's so much automation that happens today that we take advantage of on a daily basis every time a plane flies. And so how do we take that very certifiable, deterministic system and translate that into something that could unlock a whole new form of mobility? So we're very focused on deterministic systems. We believe that AI and non-deterministic systems have a great place in the future especially. But right now, for us, we're focused on deterministic. The other part about software that I would say, and I know one other point after that, so the other part about software is cybersecurity. We have all experienced, I personally have been hacked recently. It's no fun, let me tell you. Someone bought 500 cell phones, mobiles, on my eBay account. I didn't even know I had an eBay account. So how do we make sure that all of us are driving cybersecurity to a level that makes sure that our first entry into service does not translate into a blue screen, right? We need to make sure that we're all pushing on the same standards that that exist in aviation today, but also leverage other standards from ancillary or adjacent industries to make sure that we're being safe and secure. The last part would be PSUs. To build on Mark's point, we need to realize that in the future, the ATM will still probably be controlled by controllers with ears and mouths and speaking and listening and that type of thing. But there's a great opportunity when it comes to service providers who can provide digital infrastructure to us that allow us to just move back and forth. If we want to move someone from one airport to another, and we're going back and forth all day, my boss uses the analogy of a gondola. For Wisk, it's going to look like a gondola. We're going to go from this place to this place and back all day long. In fact, it will probably be the most boring thing that an air traffic controller looks at all day long. It's going to look like Pong for those of us that are that old. So when you think about it that way, it's going to be boring. And so why not give that routine task of air traffic control and air management to a software, to a service provider, like a PSU that's one term we use. So,
Change your eBay password?
I have changed my eBay password.
Okay, good.
Thank you for asking.
All right.
It's 1, 2, 3, 4, 5.
Maybe just on the software issue, I think we all agree here that the key to the future of air traffic management is data. And the management of that data. And software is the means to manage that data. It is the enabler for using this data. And what are the enablers of the software for the future ATM? You said it, cybersecurity will be an enabler, and safety of the systems. So we need to have trusted software. And the challenge is that how do we achieve that trust with a balanced cost, with a balanced flexibility, with open systems, and that's not that easy. That's a challenge for the coming days. Thank you.
All right. Inside 10 minutes, so I'm going to ask the question that I wanted to ask as my panel. So, and somebody mentioned it already. Well, all-weather operations, I want to talk about it, or how close can we get to all-weather operations, on day one and then on day, 1,000? I think Valerie said almost all operations, so I'm going to put her on the spot.
I do say almost all. We talk about that a lot at Over Air. We definitely intend for our vehicle to be able to operate not just under instrument flight rules, but in instrument meteorological conditions, because, again, it's about scaling. If somebody can't trust that most of the time this aircraft is going to go when we say it's going to go, then they're not going to use the service. We don't scale. We don't have commercial success. So yes, we're creating an aircraft that we're not planning to fly into known icing to start, but we plan to do most other things. And the challenge, of course, coming back to operations and to air traffic control, is that we've all flown where you're like turning left or right to avoid, right? Even though we're only flying at between 1,000 and 3,000 feet, let's say, this is still a challenge. But this is really absolutely key. We have the power reserves and the performance in our aircraft to be able to operate not only in these instrument conditions, but also in gusty conditions. If you're operating in mountains, if you're operating around in urban space where you have some interesting weather, interesting wind, you have to be able to have the power reserves to manage this and manage it in a way that it's comfortable for passengers. So the aircraft design is around the weather, being able to handle weather, and then of course being able to handle the weather within the airspace constraints that exist. Absolutely critical.
All right, sticking with the manufacturers. What do you got?
Oh, I'd love to ask how many people like to fly in turbulence, by the way. Yeah, in clouds, yeah. As a pilot, I do not. It's not fun. But so when we look at, from Wisk's perspective, when we look at the opportunities that exist, many of them, the bulk of the day is, in most places, luckily that we're going, the bulk of the day is actually a beautiful day. And so for us, that's where we're laser focused, is how do we make sure that we can do that part right and do it well and do it safely. Then we can move into, what do the more advanced operations look like, where we will all get to enjoy being at 2,000 feet and bumping around like you are in a Cessna. We can all get to enjoy that in the future, but right now let's focus on just making sure that we're doing it safely and during visual day conditions.
So from Eve's perspective, we're a manufacturer, but we're not an operator, and so it will ultimately be up to our operating partners to decide what conditions they want to fly in. We're building an aircraft that will begin with the pilot on board, that is intended for VFR conditions, and over time will be emerging from piloted aircraft to remotely piloted aircraft, and then eventually autonomous operations as soon as the technology and the regulators allow for that roadmap to exist. I tend to agree. It's certainly not our intention to fly into known icing conditions, and even in colder environments when the freezing level is at the surface, the eVTOL can still fly so long as you're not flying into known moisture. And so it's good for everyone to know that extreme cold conditions are okay as long as you don't fly into known moisture. Also, every aircraft has a POH, and in that POH has something called a maximum demonstrated crosswind, which is the type of crosswind that the manufacturer expects the average pilot to be able to navigate safely. Again, that's up to the operator to decide what types of gusty conditions would be appropriate, but also comfortable for the passenger. We want you to enjoy your experience in our aircraft, and we want you to rely on it. There's certainly a balance between a commercial operation that passengers expect to take off when the passenger has paid for that flight to take off, and then when it's safe. And as you all know, pilots and operators today make that go, no-go call every single flight you take. And so what it really comes down to is passenger comfort and, of course, safety. And we're all, I think, on the same page that it's all about those two factors.
Being a guy who covers the airlines a lot, the good news is they're beginning to lower passenger expectations on that reliability thing. So I think they're setting you guys up very well. Antoine or Mark, any on all-weather operations, either one, both of you?
Okay.
Sure.
I think day one we are going to provide to this fantastic industry classical systems, but very compact, very sure. So we are speaking of flight controls, we are speaking of lightweight cockpits, we are speaking of connectivity. Day 1000, it's a much more extended view of what the avionics system has to provide and support. It has to be integrated into the UTM in a very efficient dialogue. It has to be able to foresee these weather conditions and to adjust to them. And this is clearly another world. So day 1000, these all-weather conditions, it's about extending the avionics systems out of the inner part of the aircraft. It's a much wider problem to solve, and this is clearly these guys who are showing the path. So we are struggling to put it on the real world now.
No, nothing
Right.
from my side. I think the limiting points are really on the aircraft or the operation side so far. So the ATM system infrastructure will have to be resilient and I would weather-less constrained.
All right. I'll throw out one from the audience, probably from the folks back here who are hanging in with us. And anybody can answer, everybody can answer. How do you think the aircraft flow should be managed across a network of vertiports? Who wants to talk vertiport? Yeah.
If you don't mind. All right, so I'll talk to them because I know they asked.
Yep, go for it.
So for us, with Wisk's with autonomy that is also supervised by a human, one of the key things that we've realized is that in any form of transportation, you have to match a human with a vehicle. So how many times have you had your rideshare company, the driver shows up and says, "I've arrived," and you look around and you say, "You lied. You are not anywhere near her." Or you go to the airport and you hear, "Well, we got good news and bad news. We've got an airplane, but we don't have a pilot." We've all heard this. And so for Wisk, and this gets to the vertiport point, we've helped deconstrain the mobility from a certain perspective because now your airplane is here and it's ready. You don't have to wait for the other side of the equation because that part of the equation is sitting in a control center that is able to vector and deal with all the contingency plans. But in general, it's going to be moving on its own, going through that kind of gondola scenario that I described. So when it comes to vertiports, it's the same idea. We'll have a person on the ground who will probably not be at the vertiport, but they'll be able to see where the loads need to be allocated and move aircraft to there appropriately. But we won't need to have, the individual that helps to operate that aircraft will be actually in a control center. So the other side of it is all of us, I think, are starting to really coalesce around what we need from a vertiport. And there are a number of vertiport companies out there. And so for us, it's a matter of how do we hand over those requirements and then say, please build these as fast as you can. But in the meantime, at least at Wisk, we're not focused on vertiports. We're going to use existing airport infrastructure, helipads, any aviation infrastructure, where we can actually take advantage of the opportunities now, so we don't have to wait for the vertiports to be built. But it's going to be awesome when we have vertiports, but it's just going to take a little time.
So as I mentioned, over air, we're going to start with operations really to prove this out, to see how this aircraft can really most effectively be deployed. So in the 2 locations where we plan to go, we're working with the local governments, with the communities, with the existing airports, and with infrastructure providers to say, where should these go and what should the flows be? And some of the discussions you need to have are, should we develop for landing and charging, or is there a landing and then taxi and park and go back out? And then how do you split things? Are the aircraft going to spend the night there? Do they have to go somewhere else all to spend the night? How quickly are we charging, supercharging? So again, as an OEM, if you want your aircraft to be successful, you really have to be engaged in there. And yes, the flows in and out, it's going to matter. Do you have a wide open space, or are you coming in kind of vertically between buildings? These are the kind of discussions that we have with all of those stakeholders, and it's really, really critical. And of course, again, the community acceptance point matters. If vertiports are where we want them to be in the future, we've got to be silent, and that's going to affect the flows as well. How often can we come in and out is going to be limited by how often the communities will accept us.
Anyone else?
Yeah, I'd love to share a few of Yves' thoughts. So part of the urban air traffic management software that Yves is building is designed to interact with vertiports and the operator of the vertiports, so that for the operator of the aircraft, we have good visibility in terms of knowing, is that landing pad at the destination vertiport or helipad available? And for battery-powered aircraft, at least for Yves, it's super important to know that we can fly as direct, as efficiently as possible. It would be tough for eVTOL aircraft that are battery-powered, for example, to hover for really any long period of time. Energy management is paramount for this industry, and so knowing with confidence that FATO or that landing spot is open and available before we take off would be crucial. And so part of, again, the urban air traffic management software that we're building is designed to interact with vertiports so that we can manage that flow, have a reliable place to land before we take off. And then that data, again, a focus on data will empower the vertiport as well as the city to best manage its resources so that we can negotiate the volume at scale to accommodate that type of a safe operating environment.
All right. I'm into the flashing red, but I don't want to cut anybody off. Vertiports, either of you? No? You can say no.
Just an idea. I think in the future the vertiports will need new technologies for all-weather guidance. And that's something we never speak about.
We a whole nother panel. You good, Antoine? All right. The audience starts asking all the good questions at the end, and I'm getting the flash in red. I think I have to go to commercial or something. But I think the panelists are going to be right back here when I'm done. Feel free to run around and ask them questions. I do it all the time as a reporter. They love it. Thank you, seriously, thank you very much for supporting Paris Air Mobility. Thanks for coming out. Enjoy the rest of the event. Round of applause for the panelists, please.
Thank you.
Thank you, everyone.
Thank you.
Thank you.